Hi, I'm Lior of Battery Ventures, and you're listening to The Real World of AI. This is a podcast about how AI is actually being used by practitioners in the real world, how it's helping developers code faster, organizations run smarter, and executives prepare their companies for an AI-first future. Join my battery colleagues and me over the next several episodes as we get beyond the hype and dive into real-world applications of AI. Let's get started. Hey, so today I'm joined by Anthony Butler. Anthony was a distinguished engineer at IBM, where he led AI and cloud initiatives across emerging markets and later served as a senior advisor to the Saudi Central Bank. He's now helping architect one of the most ambitious AI projects in the world, HUMAIN, which is part of Saudi's $100 billion initiatives to build sovereign AI from the data center up. Anthony is also a close advisor to a company called Realian Technologies that are building a bridge to support implementation of cybersecurity technologies in government environments. In today's episode, we talk about how agentic AI is transforming enterprise productivity, how cybersecurity teams are being reshaped by autonomous systems, why identity and access control need a rethink in an agentic powered world, and how governments and banks are already putting agents into production, not just pilots. Let's dive in. Anthony, thanks a lot for joining me today. Pleasure to have you.
Thank you. Pleasure to be here.
Let's jump straight into this. I would love to hear a little bit about your background. You worked across some of the most complex and high-stake environments in technologies, from IBM to the Saudi central banks and now HUMAIN. Can you walk us through the arc of your career, how each chapter shaped your thinking about AI?
Sure. So my career really started when I guess I was 8 years old, and my parents got me my first computer. And then within a couple of years, I had developed some commercial software, and I realized that there was tremendous power with technologies like computers to transform businesses and so on. And so I spent a lot of time working at home with computers from a very early age. When it came time to go to university, I thought I know everything about computers, somewhat naively. I would do something that's far removed from the thing that I'd been working on for such a long time, which was anthropology and economics. When I finished with that, I realized that it was very difficult to get a job in that domain, and so I reverted to technology and software engineering again. And I got an initial job with a bank, working on what was an early data warehousing project, where I was developing some cryptography algorithms for them to help with secure movement of data on and off the mainframe. Then I left that. I took a job working with a large telecommunications provider, where I was brought on board to help them solve what was essentially a very complex optimization problem, where they had to work out the optimum sequencing of activities in order to perform some very large scale, national scale upgrade activities to their infrastructure. So I was able to develop some approaches to that was able to solve a problem that was going to take weeks and weeks of human effort, was able to solve it in a very, very short space of time, relatively speaking. And at that point, I became very interested in optimization and how we can use technology to solve very, very complex problems that are intractable for humans. Which led me to do a master's in operations research, where I was focusing on some novel approaches to solving, again, scheduling problems using optimization algorithms. After that, I got a job with IBM, and then had an initial period with IBM where I was helping them with one of their, again, telecommunications clients. I left IBM for a short period of time. I took a job with the Department of Justice, where really it was one of the first AI projects that I worked on, which was taking all of the data related to the prison population and being able to perform analytics on that, make certain predictions, etc. So it was a very, very early application of AI using sort of classical symbolic methods. But that really sort of captured my imagination. So that would have been in the, I guess, early 2000s. Early 2000s, so cool. Just after Y2K. And so that was really captured my imagination about the potential. then I rejoined IBM, and I had a very, very long career with IBM that started off in Australia, in Melbourne, Australia, where I was living at the time, where I was working as part of the services organization in IBM, where I got the opportunity to work with, really, really interesting clients on some really, really interesting problems. So I worked with the banking sector, the telecommunications sector, the government sector, the insurance sector. So through IBM, I got to see the scale of problems that clients have, and how technology can or cannot help them solve those problems. And the last customer, or the last project that I had in Australia, was with the mining industry, working with a very large global mining company. And through that, I got to work with emerging markets, because the types of locations that mining sites are in are typically, quite remote, right? I mean, it's not typically cities and so on. So I got to work in Latin America, I got to work in Africa, in Asia. And then when that project ended, I was really, captivated and interested in emerging markets, because I saw that there was really an opportunity to have a great impact, but also they were not burdened by a lot of the legacy technologies that existed in the so-called mature markets. And so with that in mind, again with IBM, I moved to the Middle East, to the United Arab Emirates, where I was hired or brought on board to help spearhead the services organization focusing on technology. Then I moved from pure services to work in software, and in software, that was we were working with sort of the Watson technology, some of the early, very sort of early AI or machine learning based products that IBM was bringing to market, as well as cloud. So I got to work at that kind of inflection point in the industry. And so during that period, I was also doing a lot of work with distributed ledger technologies, DLT, blockchain. So I had the opportunity to develop some national level strategies for some countries in the region, helping them understand how this emergent technology could be used to transform the business of government and drive new efficiencies into how they deliver services to their citizenry. And in recognition for the innovative work that I'd been doing in cloud, in AI, and also in blockchain technologies, I was appointed as distinguished engineer by the chairman of IBM, and I was the first distinguished engineer from the region. And so that
It's a
was
pretty
really.
impressive title by itself, right?
Thank you, thank you. And it's it's quite hard, because it's not just about delivering value for clients. You also have to create intellectual property. You have to contribute to the body of knowledge within a certain discipline. You have to mentor. You have to be really quite a well-rounded profile in order to get through that process. And it is quite a process with multiple tiers of approvals before ultimately your case gets presented to the chairman.
Amazing.
So that was a great achievement. And then I was given the opportunity to move to Saudi Arabia, and at that time I had been working a lot with Saudi clients anyway, because it was one of the major growth markets in the region. And so I joined the consulting organization in Saudi, where I was responsible for the public sector. And through that, I got to again work with some really, really interesting clients on some really interesting problems, and see how there was the potential to transform the way in which they were conducting their business, using some of the technologies that IBM had, as well as partner technologies. And then the opportunity came. So after, you can imagine, like a very, very long career working across, pretty much everywhere on the planet with IBM. But from the
That was
service
what,
provider.
like 15 years?
Sorry?
That was like what, 15 years at IBM?
Yeah, 15, 16 years with IBM. And so always I'd been on the service provider side, so I'd always been the one providing the services to the client. And so that gives you a certain perspective, but it's not the complete perspective. And so I was always thinking it would be great at some point to move to the other side of the equation, or the other side of the table, so that I could understand things from a different perspective. And so I had the opportunity to move to the Saudi Central Bank, where I joined their innovation hub. And as part of that, I was focused on carrying out experiments with emerging technology to help the sector more broadly understand how these technologies were transforming them, or have the potential to transform them, to also help the regulator understand how the business of regulation could potentially be transformed through these technologies like AI, but also to understand what it means for the sector, or what it means for the regulatory frameworks that exist. Does it create new risks? Does it create new challenges? And so that was really a great experience that gave me a completely different perspective on how some of these technologies that I'd spent all of my career building and implementing, how they have, in some cases, second order impacts that I hadn't even, necessarily thought of. And AI is a very, very good example of that. What are the economic and social impacts, regulatory impacts of widespread adoption of AI? Um, so so that was working then on the regulatory side, and then I was approached by the Saudi Data and AI Authority, SDAIA, to take a position as chief architect with the National Center for AI. And so in that effort, or in that initiative, I was focused on really looking at how this company that became HUMAIN could be structured from a technology perspective and an architectural perspective. And then when HUMAIN was instantiated or born, I moved across to HUMAIN, which is where I currently sit and serve as the chief architect.
Congrats, by the way. I saw this is a kind of a new announcement for you.
Yeah, very, very exciting. Thank you.
Perfect. So you have quite a lot of that, and I'm looking forward to dive into some of the use cases. As you know, this show is about AI in production. So I'm curious to get your perspective into some of these areas you looked through in the last decade or so, but maybe starting from the end and talk about the big elephant in the room. Humane is kind of backed by the Saudi PIF, 100 billion initiative. And as far as I know, it's a new full stack AI company. And wanted to hear from you and get a little bit more perspective on like what's the ambition here, what's the problem that human is trying to solve that no one else is.
Yeah, so I think, as you would have seen from the announcements, it's a full stack AI company. It looks across the entire value chain, which I think is really the unique differentiation or value proposition, I guess, for the company and what makes it very different. And if you look at the value chain of AI, people tend to focus on the models, or they tend to focus perhaps on the applications. And if you look at the companies that exist in the world, they're typically focusing on one or a handful of things. Whereas I think what is unique and interesting about HUMAIN is that it's consolidated the entire value chain. So it's from data centers all the way through to cloud infrastructure, through to the models, and then ultimately to the applications that are built on top of that. So it's really that bringing together the entire value chain that I think is quite unique and interesting.
Well, what's the advantage that you expect from owning the full stack that you can get if you're just an application layer using public clouds?
Well, I think there's a tight integration between all of those things. Like if you are able to engineer systems for sovereignty, engineer systems for resiliency at an infrastructure level, at a base infrastructure level, and then build on top of that, I think that gives you um, the ability to engineer solutions that are more optimized than if you're building them on a stack that you don't necessarily control.
Got it. And I've seen online that you've said it's not just about kind of the infrastructure; it's also about sovereignty. And I'm curious, what does it mean in AI context from your perspective, and why it's becoming sort of a national priority in the MENA region? And if you think it should be replicated in other places as well.
Sure. So, I mean, when we talk about sovereignty in the context of AI, it's more than just hosting, right? It's more than just having a physical box sitting within your jurisdictional boundaries. When I think about sovereignty, I think about it with multiple levels. So I think about obviously the physical independence, so making sure that you have the physical infrastructure that's required for both training and inferencing within your domain. So that means making sure you have access to the GPUs and so on and so forth, making sure that you have access to the skills to build and operate all of that. Then when we get to the sort of the more technical elements that are built on top of that, it's about, do you have the freedom and the ability to train and customize your own foundation models, whether it's large language models or whether it's models that are trained on some other specialized industry data set. And that's obviously requires human capital, it requires research infrastructure, it requires an understanding and control over the development lifecycle for these models. And then we talk about operational sovereignty. So Are you able to operate all of this with domestic talent? Do you have enough AI and machine learning engineers in your country in order to be able to deploy AI at the scale that you need? Do you have the ability to control the data that gets used to either fine tune or train these models, and so on and so forth? So really, when I think about sovereignty, I think about many different levels to it, and even things like culture. So making sure that the models that you use within your country align with the history of that country, align with the cultural values of that country, the language of that country. So I think sovereignty is much more complex and much more layered and much more nuanced than just having some GPUs and installing them in a data center that happens to sit within your jurisdiction.
100%. I agree. But it sounds like a lot of effort and resources being devoted to this. While at the same time, if we're looking outside in the world, you and I talked about this kind of AI productivity paradox. We're seeing everyone using GPT kind of as consumers, but enterprises are not seeing the returns that they expect. What do you think is kind of broken in how AI is being used today? And maybe it's part of what HUMAIN is trying to solve, or maybe you have perspective or what general enterprises needs to do to like start seeing some more ROI on that AI hype.
So generally, if you're right. So if you look at the productivity improvements of AI, particularly generative AI, let's talk about generative AI, and GPT is the sort of the classic example of that. I think most of the productivity improvements and productivity and benefits have accrued to the individual and not necessarily the firm. And in some ways, it replicates things that happened when computers first started to permeate the economy. I think it was Robert Solow who famously said, "You can see the computer age everywhere except in the productivity statistics." So I think what happens with these technologies is that the individual is using them. So the individual is using GPT in their day-to-day work. It's allowing them to create documents faster. It's allowing them to review things faster. But that productivity improvement is not being accrued or generated at the firm level yet. It's just that this person is now like slightly more productive, perhaps. But what are they doing with the excess capacity that technology is freeing up? Is all of that being diverted in the service of the firm, or is it not? So I think there's still, that could be one reason. And also, it's a very new technology, and it does take time for a lot of these things to start to be visible economically. But I think we're at the beginning of an inflection point when it comes to productivity.
Yeah, I think the word productivity is a little bit vague. If for an enterprise, either you're improving the top line or you're making some cost saving, and just productivity in the middle is just a little bit vague and not clarified in terms of ROI. But I agree. So you had this experience with IBM in the early days of AI momentum. What can you elaborate and tell us a bit about how organization like IBM use AI for, or maybe was your clients? Just curious, as you had a first row seat
Sorry,
into
Leo,
when.
it's completely garbled. I can't. It's like I cannot hear the question. I cannot hear you.
Okay, let's repeat this. Can you hear me now?
Yeah, but it's like an echo. It has a metallic sound.
Is that new?
It was before, but it got worse now. Try again.
Okay.
Ask me again.
How is it now?
Yeah, try.
How is it now?
It's okay. Try.
Is that better?
I can understand.
Okay, that's weird. If you need to reconnect, I can try. But let's go back to your days at IBM. So you spent 15, 16 years there. You saw the AI momentum just starting. Can you tell us some examples of real world use cases of how like large organization like IBM use AI or LLM, especially was the early days? Can you share some of the
So
client use cases?
sure, sure. So there are lots of interesting use cases. This is pre-generative AI. So this is before Chat GPT and so on. So AI didn't start with the emergence of GPT, but GPT was kind of the Netscape moment in terms of popularizing AI with the general population. So some of the really interesting projects that I worked on with IBM, or things that I saw with IBM. So firstly, although I didn't work on it, IBM was really, uh, I think, successful in building these early conversational agents that allowed things like HR processes and so on to be automated through a conversational interfaces. So one of the things I missed from my days at IBM was how easy it was to book leave or inquire about leave balance, or even things like giving performance bonuses to my staff using a purely conversational interface. So IBM was a very early internal adopter of AI, and I think that that's something that still continues to be a very high value use case. Um, then with clients, some of the really interesting things that I got to work on was within the field of sustainability using geospatial data, so satellite images. So using satellite images to be able to detect, so satellite images, obviously they give you images of the land mass, etc. But with spectral imaging, you can also see certain types of emissions, and some of those emissions can be proxies for economic activity, but some of those emissions can also have sustainability or environmental impacts. So I worked on some interesting projects using this geospatial data to identify certain types of gas leakages using this technology. Also, I worked on, which was also very, I think, very interesting and still continues to be a high value use case, was some exploration around materials science. So if you look, and this was really sort of at the emergence of generative models, where just as those models are able to learn the language of English or the language of Arabic or the language of French or the language of German, it turns out that the language of chemistry has similar patterns or has similar structural elements to human languages. And so I worked on some efforts with the research team to look at how we could apply some of these models to invent new types of materials. So materials, for example, that could be highly effective in carbon sequestration, which is a problem that many countries face in terms of how can they develop efficient materials to absorb CO2 and store it for an indefinite time period. So that was another interesting project.
Actually, curious if this is kind of the equivalent of large language model, but just, I don't know, like large chemistry model, and the
Exactly,
equivalents for each field you work
exactly,
on.
exactly. Um, and so that particular project, I was working with researchers in Zurich labs, and so we would using the models to generate these candidate chemical structures. Then there'd be an evaluation process, which in some ways is analogous to what is happening in the language domain today. And then they would carry out some experiments, some simulations based on those candidate structures to see which ones would be able would have a high probability of being synthesized in the lab, would have the right characteristics, the right stability, etc. So this was, this is really at the early stages of generative models, but it was interesting because the observation I got from that is that there are many things in this world that have a language type characteristic, although they are not necessarily human languages, and so these models could be broadly applied to them.
And I assume this was a couple of years ago. I'm curious how this is close or similar to the agentic framework that people are talking about today. Like today, everyone is agentic and everyone is talking about digital coworkers. Um, what kind of the spread between what you've been working and building there then to what you're seeing now? Is this kind of a similar, or what's the jump that we've been went through technology wise?
Um, so firstly, the entire concept of agents is not a new concept. I think the first certainly from my as I recall, the first mention of agents was Marvin Minsky back in the sort of the 1980s, when he was trying to describe the way in which human cognition works as agents that are focused on discrete tasks, and together they form this kind of society of the mind. And since then, you have, Rodney Brooks, you have many sort of giants within the AI domain who have spoken about agents. And there are many efforts as well to try and sort of create these multi-agent swarms and so on and so forth. So agents in and of itself is not a new concept, but what is new, as with many of these things, is that because we have large language models, because we have readily available compute in the forms of GPUs, a lot of these things have become more viable. Now, what's interesting about agents, if I go back to the problem that I mentioned around how productivity gains from AI are mostly accrued to the individual and not being passed on to the firm, I think agents are one mechanism by which that can be addressed. Because if the agent is able to take on an entire task or an entire activity or an entire function on behalf of the firm, then it's directly creating value for the firm, as opposed to it being a tool in the hands of the individual that the individual is using and is driving. So I think agents are incredibly interesting because of that ability to create or that line of sight to productivity improvements. But also, again, this is an old idea. If you go back to Coase and the theory of the firm, why do we have firms the way that they are? Why do they have the shape and the structure that they have today? It's ultimately because of transaction costs, meaning you can't go to the market every time you need to hire someone and get an HR company to process their onboarding. It doesn't make sense that every time you need to sign a contract, you need to go to the market and find a law firm, right? So because of these transaction costs, that's why we have legal departments, HR departments, et cetera, et cetera. Now, what agents are allowing us to do, I think, is to reimagine the structure of the organization, because we can have human workers that work alongside agents, which allows us to, from an HR perspective, think about how we refactor the organization in similar way to the way in which we refactor code. So we can have much smaller organizations that are ultimately much more efficient and more effective because we have these agents that will work alongside humans ultimately.
How close are we, do you think we are, kind of from mainstream adoption of agentic system in the enterprise?
I think within certain domains, we're already there. So within the software engineering domain, I think that there is already significant amount of value that's being created from the use of agentic approaches to software engineering. I think in some of the creative domains, I think likewise there is already real world applications of agentic architectures to create value within the creative disciplines. I think in some domains we're already there, and others it will take some time. But what's interesting to me is really how software engineering has been transformed by these agentic architectures, and I think that is also going to really transform the way in which we think about software development, the skills that are needed from software engineers in the future, how we articulate problems, etc. So that's probably where I see the most immediate benefit and the most immediate application.
Can we leverage some of your background in security and shift gears to talk a bit about the risk of using agents? So if you have a system of agents acting kind of autonomously, making decisions, taking actions, what's your perspective on how we ensure the trust, the oversight, the control?
I think this is still an unsolved problem. But the problem that we have is essentially that the agent is an agent. The agent has agency, and that agency is ultimately on behalf of a human. So how do we make sure that the agent can only see what its human principal can see? How do we make sure that the agent can only perform the activities that the human can perform? Because one of the challenges with the agent is that, or the agents, is that they have access to many different systems, many different data stores. So I think identity is really an unsolved problem within the agentic world. And the problem is essentially, how do we extend the human identity and the human permissions into the domain of the agents, so the agents act within those constraints. And I think that is very much a challenge that needs to be solved if we're going to scale these agents more broadly.
Do you think like the traditional IAM vendors would be the most appropriate to tackle this space, or you think permissions would have to be, I don't know, built dynamically in real time? and it's sort of a new technology.
I think the way in which we think about permissions needs to change, in that it's not Anthony has access to this resource, has read access to this resource, or delete access, or create access. I think we need to think of permissions more as a graph structure, because agents will spawn agents that will spawn other agents that will instruct agents to do certain things, right? So it's not highly non-deterministic. So it's not possible to model it as a very simple sort of relationship. So what I think is that there are efforts, or there were efforts in other domains, such as Google, for example, has something called Zanzibar, which was the way in which they implement identity at sort of cloud scale, which is again using a kind of graph structure. I think there's learnings and concepts from adjacent domains that can be brought into this world of agents, and I think IAM vendors will need to extend their IAM concepts into the agentic world if they are to stay relevant.
Interesting. Have you ever deployed an agentic system that backfired, um, or you exposed a blind spot you hadn't anticipated?
Um, Yeah, I mean, in software, in software engineering, definitely. I've done lots of experiments with agents for creating software. And I mean, there's some interesting things that you see. So one is that unless you instruct the agent properly, often the code that will be generated will not be secure, and it will have vulnerabilities inside the code. And in some cases, are very obvious vulnerabilities. So I think we need to treat language as a higher level of abstraction, as a more abstracted programming language. And just as in a programming language, you have to be very explicit and make sure that it's complete. Likewise, when you convey the instructions using language, you also have to ensure you have similar levels of completeness and preciseness. And also, there needs to be human in the loop. So I think there's been many cases where people have developed code using these agentic architectures, and the code has been insecure, has not been performant, or has had other issues. So yeah, I mean, I think that's something that is very very common. And now there's different ways to mitigate it, but yeah, I've seen that many times.
Yeah, I think the problem today is companies still scared and worry about all this stuff, and they're stuck at the pilot stage and not taking into production. But maybe it's a good segue to talk a little bit more on kind of production grade deployments you had. And you mentioned earlier some of the use cases at the Saudi Central Bank. Can we double click on it and talk about some real business value that was driven? Where did you deploy agent? What did they do? How did you measure the ROI? And what actually was kind of the task they completed?
Um, so in general, the way in which you measure ROI with agents, it should be the same way in which you measure ROI in any kind of software development project. Whereas we mentioned before, you should focus on efficiencies, accuracy, improvements in customer service. So having the ROI
Or
defined
revenue
upfront, I
generation.
think, sorry,
Or revenue generation.
or revenue generation, exactly. So I think if I take a step back, in order to get these things into production, um, firstly, why don't agentic or AI projects go into production? And the number one reason that I've seen across everywhere that I've worked over all this time period is that if you are just doing a POC for the sake of proving a technology, you're just doing a POC to learn about a technology. You don't have a business owner, you don't have an ROI defined, you're not solving a real business problem, but you're doing something that you think might solve a business problem, but it's not really confirmed that it is a business problem, and it's not quantified. I think it's very hard to go from proving a concept to taking it into production. I think there's been an awful lot of POCs. I mean, AI is no different to other emerging technologies. I saw the same thing with blockchain, with distributed ledger technologies. It's very easy to be stuck in the POC stage and you can't graduate to production. And I think that the lesson learned is that you should start with the user problem. What is the problem that you're trying to solve? What is the business efficiency that you're trying to create, or the inefficiency that you're trying to mitigate, and work back from that? If you do that, then AI is just an enabler of a solution that delivers that outcome, as opposed to what could be the case and what is an anti-pattern in that AI becomes the sole focus. So it's all about the AI. It's about doing an AI project as opposed to solving a business problem. And so those projects that have gone into production using generative or non-generative models have all had a very, very clear ROI defined up front, and AI was just an enabler. It wasn't the sole focus of the project.
So what would be like a one simple use case? I don't know if this is like a making a compliance review or making like a research task that worked really well.
So summarization of documents is something that works really, really well, that large language models are very capable at doing. And so you find this across all industries. So I've seen it in banking industry, I've seen it in regulators, where you have a very, very large amount of textual documentation that you need to compress to a summary. That's something that is very well proven. It's relatively low risk. And I think that that's across all industries, that's something that can generate a lot of value. That's one. Secondly, I've seen,
Can you just use like GPT or any of the off-the-shelf tools, or because you're in kind of a government environment, you have to develop your own thing?
it depends. So some industries are able to use cloud-hosted technologies like GPT or Claude or whatever. Others, they need to deploy something on-prem. And there are now models that can be deployed on-prem that can be even in an air-gapped environment, for example. So there's models that have been developed even in the region that can be deployed in that way. It really depends on the use case, and there's obviously trade-offs between the two. And I think, I mean, that is a good point. I think as we're moving forward with more and more production scale deployments of this technology, particularly in regulated industries, there is a lot of concern as to where those models run. And so the obvious concern is, where is the data going? It's leaving the country, et cetera, et cetera. But there is also a more sort of second order concern, which is nonetheless very important, which is concentration risk. Because if everyone in an industry or everyone in a country is using GPT or is using Claude or is using a particular model, it creates a concentration risk. Because if something happened to that model, if it, for example, it failed, that the impact of that is very significant. So I think when we start to design these agentic or AI-based solutions to different problems, looking at what is the data that will be fed into the model, what is the resiliency requirement of this application? Can it be accepted that it has a dependency on cloud-based infrastructure, or should it be something that's on-prem? All of these are decision points that need to go into that. And the good thing is now we have so many different options. I mean, there's the Llama family, there's Quen, there's so many different models that can be deployed on-prem. It's not limited only to the cloud. But these are all things that need to go into the initial design of the solution.
Yeah, interesting. So if you were to advise some enterprise AI leader or an executive, what would you tell them to stop doing today, and what they should be doubled down on in the next 6 to 12 months?
I would say stop doing POCs. If you're in this flywheel of just doing proof of concepts, I would say stop. Find a real problem that AI can address, and focus on that problem, prove it, build the confidence, and then start extending it to sort of more agentic, more sort of non-deterministic workflows based on that. But definitely, I would say just start with the business problem and pick something that is relatively low risk.
And your recommendation would be to kind of build versus buy because of what you just said. Starting from the bottom, find the smallest use case you can solve that gives business value, and then go from there. Um, Sounds like this is something I'll have to build internally or leverage some of the open source projects out there rather than buy a platform and reshift my entire sales organization.
Really, it depends on the organization and the use case. So if you have an organization that has a heavy focus on digital platforms, social engineering capabilities, software engineering capabilities, not social engineering, software engineering capabilities, absolutely, it makes sense to start building things and understanding how these models work, how to test them, how to monitor them, the operational aspects. I think building those capabilities in your technical team, it has immense value. But if you're an organization where technology is not fundamental to what you do, then maybe it makes more sense to just procure a turnkey product.
Is there any belief you hold about the future of AI or agentic systems that would surprise or challenge most people in the industry?
Um, so I do think that there will be a convergence of HR as a function and agent management as a function. That as agents become more and more akin to digital workers, that just as HR is responsible for shaping the organization, defining the organization, managing the spans and layers and control, etc., that the same thing will need to be done with agents. And so I think there will be a convergence of those two functions. Can you hear me?
Yeah, you were frozen for a minute. I hope he recorded you. Can you hear me now?
Yeah, I can hear you.
Okay, I hope it worked. If it recorded on your side, we'll be good. Um, cool, Anthony. This was super insightful conversation. Before we wrap, I have a couple of small questions for you that are kind of a reflection and maybe philosophical, but I'd love to get your input on them. Starting on, do you think, like, how far are we from seeing something that truly resembles AGI?
I think we're probably further away than what some people would suggest. I think we are a long way away from AGI. And the reason is because there's many reasons, but if I look at how these models work, I don't think they are truly thinking in the way that human cognition is operating. Even the way they learn, like the way a human learns, isn't by reading thousands and thousands of books. So I think until we are able to build systems that more closely resemble the way in which the human brain operates, both from a learning perspective and an inferencing perspective, I think we are some way away from AGI.
Okay, fair. There is also a question of what exactly is AGI and how we define it, but let's leave this for later. Um, Putting AGI aside, on kind of more enterprise use cases, what do you think is kind of the next 12 to 24 months hold? Are we heading into a breakout moment, or there are still tailwinds we are not fully acknowledging, like we discussed with cybersecurity and identity?
Look, I think the for the next 12 to 18 months, I think there is going to be a massive amount of value created within the software engineering domain. I think now we have agents that can run for hours, for days, for weeks, with some human course correction. But the fact that we can have very long running agentic processes is going to really open up some really interesting possibilities. The fact that the marginal cost of running these agents is also decreasing means that now we can do things like have multiple agents addressing the same task at the same time and then evaluating the outcome, fine-tuning that, correcting, and then iterating. So running sort of almost like a Monte Carlo simulation with multiple agentic paths. I think that that's also going to allow us to do things that are currently very difficult to do or very difficult to assess. And I think the third thing that we're going to see is one of the challenges with all of these, with agentic workflows or AI in general, is how do you prove that the outcome is the right outcome? So I'm hopeful that we will see some innovations in formal methods and the applications of different approaches, most of which predate generative AI, but bringing that into this world so that we can start to prove that the outcomes that AI is giving us are optimum. So I think there'll be a lot of improvements there. And again, I think most of the focus or most of the value will be in software engineering.
Amazing. And what, as a last question, what you would be the most excited about personally in the AI space right now?
I'm really excited about long-running agentic workflows where you can give it a task that's extremely non-deterministic, and have the agent run for an extended amount of time just to solve that task. I think that that is something that really excites me. Also, I'm very excited and interested in how these agents are allowing people to accelerate and amplify the creative process, whether it's creative in terms of the arts or whether it's creative in terms of software. I think the ability to use the model as a sounding board, to test things quickly, iterate fast. I think it's going to accelerate human creativity, particularly within the world in which I operate, which is engineering. So that really excites me because I can see already the benefits.
Amazing. Anthony, this was a super insightful and fun conversation to have. Really appreciate you doing this. Just to summarize for our audience, this was Anthony Butler, Chief Architect at HUMAIN, with a powerful view into the future of AI, which is not just a tool, it's a system that acts, reason, deliver value at scale. We agreed agentic AI isn't science fiction. It's being built right now, also by governments, by banks, infrastructure providers who are not waiting for the hype to pass. They're already deploying it. So thanks everyone for listening. And Anthony, really appreciate you coming over to the show.
Thank you.